Hello ladies and gentlemen, and welcome to section 7, Building Machine Learning Models with Scikit-learn. In this section we are going to look at different machine learning models for solving the problems of regression, classification, and clustering. We'll be learning particularly about linear regression, logistic regression, k-nearest neighbors, decision trees, random forest, and k-means clustering. I am very much excited about this section because we are going to not learn about those algorithms, but we are also going to learn how to implement them in Python using Scikit-learn. Alright, so let's get started with linear regression. Regression algorithms are used when the outcome of interest is a continuous variable. Linear regression models the relationship between the dependent and independent variables in a linear way. The fitted model produces a linear line or surface for higher dimensional data, which is used to predict the outcome of new data. The model tries to minimize the total squared error between the predictions and the actual outcomes. This is often done by using the least squares method. So, there is basically two linear regression models that we're going to learn about. One is the simple linear regression and the other one is multiple linear regression. In the simple one, we are predicting the outcome variable y by using a single input variable, x. And we are going to fit a model that will predict the beta 0 and beta 1 coefficients, beta 0 being the intercept, and beta 1 is basically the slope of this line, so that our error epsilon is minimum as possible. Okay, it's the same idea with multiple linear regression, only in this case we are able to use more. So since we have more variables at our disposal, more input data, we have more columns or more features, we'll be fitting beta 1, beta 2 up until beta k coefficients if our data is k-dimensional. Alright, so how does this work? Well, if you have data like this, now you can directly see that there's a line like this that should fit, through these points perfectly with no error. And you're right. As you can see, this line goes through all those points with zero error. Perfect case, not realistic. Let's see how it is in the real world. Well, this is a more realistic case. So we have a scattered data set here, but still there's some linear trend here. Okay, so what the linear regression model does, it finds this line that goes through these points, and this line reduces these errors as much as possible. Okay, so it fits this beta 1, beta 2 and whatnot, all these coefficients, such that this epsilon value is as small as possible. And this is called generally the least squares method. With that being said, let's go to Jupyter environment and let's start coding. We'll be importing pandas and numpy, and we'll be also importing seaborn, because I will show you, you've already seen the top of it, but that plot later on. And we'll be using scikit-learn datasets. As I mentioned, scikit-learn can import some datasets from outside and also has some built-in datasets. And we'll be using the wine dataset of scikit-learn. And let's do that. So we have imported as data. Okay, so if you say data dot, you can see a bunch of different things here, but we'll be using load wine. So you can see it has some different things here going on. It looks like a dictionary. So when we say wine, let's save this into a variable called wine. Now wine, what is wine? Let's look at the type of wine. It's called sklearn bunch. Okay, now this is basically, you can think of this like a dictionary. Okay, that's the important by here. So it has the data, the target names, a description of the dataset, and the feature names. So for example, if you want to see the description, let's see that. Okay, so this is like tells about the data, gives some information and whatnot. So let's get rid of that. So wine.data has the data in it. And so if you look at wine.feature names, it has the feature names in it. So we can use these two to create a data set, right? pd.dataframe. So this is the columns. Perfect. So we have our data set here. So let's save this in the df. Good. And we'll also save this target variable. So let's see what target looks like. df.target. I saved it in the wine and I forgot about it. Okay, so it's wine.target. Okay. So we can see values 0, 1, and 2, discrete values. So this is a categorical variable. Okay, it shows the wine types. So we'll save that as wine type. We'll add it to our data set. Okay, wine.target. Good. So we have our data set. And let's look at some info on this dataset. Okay, so there's no missing values, all looks good. And so we'll start with a linear model here, a linear regression model. And we'll do two examples, one simple linear regression model, and the other is a multiple linear regression model. Before doing that, let's do this. Okay, so I have already created this, pair plot using the data frame because it takes a bit to run all of these variables together. But basically what we'll be doing is this. Let me show df.head. So this is the target variable, the wine type, right? And it's of a categorical type. Now we'll be using this dataset throughout section 7 to learn about the different algorithms. And there, in the other ones where we'll be doing classification, we'll be using this column, the wine type column, as our target variable. But in this case, since we are doing linear regression and regression in regression problems, the outcome should be continuous. We won't be using this one. Okay, we'll be avoiding that. We'll be using alcohol. So we are going to try to predict the alcohol value by using other features in the dataset. Okay, so, and when you do the pair plot, you can see alcohol over here. So for the first example, for the simple linear regression case, we'll be using only a single feature. So if I were to ask you to choose a single feature out of all these features, which one would you choose? Now, this is alcohol over here, and these are the rest. Basically, these are the other features. Okay, and this shows the scatter plots between the two. So question is, if you were to choose only one, which one would you choose? So you can pause this video and then look at it. Okay, so assuming you have done that, without going into like any statistical details or anything, I will just look at the data and choose the one that's like basically the highest correlated with alcohol, right? So we are trying to predict alcohol. And this seems very, like random, this too, this, yeah. There's some structure here, but still no, not really. Yeah, I see something. It's quite, there's a upward trend here towards right. This looks random, this one also looks random. This also quite an increasing trend here. So if I were to choose one, I would definitely choose either this one or this one. Let's look at those two columns. So one is color intensity, the other is proline. Now between the two, it seems like, well, they are very similar, but I'll just choose proline. Okay, let's go with that. So I do hope that we'll get some good model even when we use a single variable like this. Let's do that. So first thing is we'll import the linear regression estimator. Okay, so we'll say from Scikit-learn dot linear model import linear regression. Good. So we have imported linear regression now, and we'll instantiate it. So I'll save that into a variable called reg. I will say linear regression, open parenthesis, close parenthesis, run, and that's it. So this is how the instance looks like. Okay, we have instantiated this estimator by using this, and reg is the instance of this estimator now. And these are its default parameters. We won't be touching them. All good. So how do we fit? Remember, so let me go into the middle like this. So we'll be using fit for this, reg.fit. Of course, before, like, we can't put df here, right? We have to have two input values here for it to be able to do the regression or classification. First is the x and the other one is the y. So we'll create those now. Let's do that. So x is df. We said we'll be using proline. And y is our outcome variable, which is df alcohol. So let's run this. Let's fit the model to the data. Now I'm expecting an error, and I did get an error. And what's the error? So I said, remember from the requirements of Scikit-learn, x should be a 2D array or a pandas data frame or a matrix. Okay, basically it should have 2 dimensions, tabular data. And y can be 1D array or a 1-dimensional data frame. That's fine. So in this case, x, let's look at x. X is a pandas series. So it's like 1-dimensional, and that's wrong. So we need to convert this to a data frame. We can achieve this easily like this. So we now have a single variable, a single column data frame, and this should solve our problem. So if you go back here, we fit the model to the data set, everything is fine. Now the next step is predicting. So we'll say reg.predict. As input, we'll give x only, and it does its predictions. We'll save this into a variable. and then checking the accuracy of this. So for that, we'll be importing. So I'll say from Scikit-learn, import matrix. Okay, so we have our matrix now. And for linear regression, it's generally R-squared value that's used for assessing the performance of a classifier or a regressor. So we'll say, R2 squared is used for regression cases, not classifiers. So we'll say matrix.R2 score, and as input, we'll be giving y-true and y-pred. Okay, so what is y-true? Y-true is the actual case, which is this. And our predictions were saved in pred. So we'll run this and we get 0.41 R-squared value. Not too good, but not bad as well, considering we are only using one variable. So with this done, let's do the second example, which is we used only a single variable here. Here, let's use all the other variables to predict alcohol. Now, we won't be using this one, the last column, because this is wine type. It's a categorical variable that needs to be converted to a dummy variable, which I won't be doing now. So I'll say d of drop, and we'll be dropping two columns. First is the alcohol, right? Because that's our outcome variable. We won't be using that as input. That will be wrong. Wine type, and x's is equal to 1. So, okay, looks good. So let's save this to x, and let's fit our instance again. So linear regression, are fitting it to x and y. Okay, so the next step was, I want you to do this now, prediction, and then R-squared value estimation. So we'll say reg.predict, we'll give x, we are making predictions. Let's save this into pred again. All right, so if we now use the same matrix.R2 score now, I am assuming, well, I'm at least hoping that it will increase, and it will increase for sure, because we are using more variables, and the R-squared value increased from 0.41 in a simple linear regression case to 0.59, almost 0.6 in the multiple linear regression case. Okay. In this video, we have learned about linear regression and how to implement linear regression in Scikit-learn. We have learned two examples.